No. Hello, welcome back to the Calculus 2. This is the review for exam 1. We did all of this list. Here it is. And then you can slow this down and look at it again. These are all the formulas and all the concepts. No coughing. And now we have the first problem. Wait, what did I just say? We have the first problem that has the surface area of revolution rotating around x. There's the function, there's the interval. And then we plugged everything in. So we are going to now solve this. That's going to be pi over 5 integral negative 4 to 4 e to the 5x plus e to the negative 5x. We'll do this the other way as well. Hopefully it's much easier, but let's just do this first. When I factor out 5s, that's going to make it a half. And it's going to be e to the 5x minus e to the minus 5x.
Do you have to square that?
Yes, it's clearly squared. Thank you. That's yes. It's obvious, right? So if I no, but see now when I factor out 5, it will be 5 squared. That's getting so that's 25. So 5 halves over here, right? Because when I factor out 5, that will be a 5 squared. That's 25. 25 over 10 divided by 5. Yes. Okay, cool. Pi over 5 integral negative 4 to 4 e to the 5x plus e to the negative 5x square root of 1 plus 5 halves, and now we square this. This is e to the 10x minus, and now there is a middle term here. When you multiply these two together, you will get 1 because it will be e to the 0, and you have 2 of them. So that would be minus 2. And then finally plus e to the minus 10x dx. So now when I distribute the 5 back into it, yeah, I don't know if we'll get anything. Anyway, this needs to go in, and it will pick up a square when it goes in. So pi over 5, and here we have a big square root, and now this is going to be times 1, so e to the 5x plus e to the negative 5x squared plus 5 halves of e to the 5x plus e to the negative 5x squared times e to the 10x minus 2 minus plus e to negative 10x. A little bit convoluted with these things, but it all simplifies nicely eventually. So that's e to the 10x plus 2 plus e to the 10x plus 5 halves times, and now we have all this mess here, and that's going to be I'm gonna FOIL this over here as e to the 10x plus 2 plus e to the negative 10x, so I can just do the foiling. Oh, well, that's the same, except the minus sign. Do we all see that? So now I am regretting foiling this, Yeah, I'm not going to FOIL this anymore. I'm going to bring it back what it was. I'm not going to FOIL it anymore. It was e to the 5x minus e to the minus 5x squared dx. Because now I can have them FOILed and have the parentheses squared at the end. So when I FOIL them, I get e to the 10x. The middle terms cancel, minus e to the negative 10x. There we go. Much better. dx. And now, when I FOIL, then I can work with the other one over here. So pi over 5, integral negative 4. Just a little bit, algebra. E to the 10x plus 2 plus e to the 10 negative. This is negative 10x here. Negative 10x plus 5 over 2. And here we have e to the 20x minus 2 plus e to the negative 20x. When I apply that square, and we can hit this with these 5/2. So e to the 10x, this is not nice. Nah. I quit. I'm not gonna waste my time. What was the problem? 1 over 10 e to the 5x plus e to the minus 5x, right? That's equal to 1 over 5 cosine hyperbolic 5x. That's the boss. So when you have that, the y prime is sine hyperbolic 5x, because the 5 would jump out and then it would just cancel 1/5. It doesn't take a lot to quit. I mean, as you've seen, it's just done. So now when we set up the problem again, it becomes 2 pi negative 4 to 4. We take the original function, which is 1/5 cosine hyperbolic 5x, times the square root of 1 plus sine no cosine hyperbolic squared of 5x dx. There we go. Now, if you studied those equations, you remember that the cosine hyperbolic squared minus sine hyperbolic squared is 1. So this is 2 pi. Well, you can kick 5 out and have negative 4 to 4. You have cosine hyperbolic 5x, and this one over here is cosine hyperbolic squared 5x. I will write the formula here in red. Cosine hyperbolic squared x minus sine hyperbolic squared x equals 1. So that's how this became that. And then the square root kills the square, and you are left with 2 pi over 5 integral negative 4 to 4 of cosine hyperbolic squared 5x dx. Now we are going to use the other identity for power reducing cosine hyperbolic, even though you can go back into ease, and you can go back to ease now and square them, but you can also use the formula that the cosine hyperbolic squared x is 1 plus cosine hyperbolic 2x over 2. and go from there. I'm not sure which page these formulas are on. I think this was in chapter 7 somewhere. These two formulas, the red and the blue. I'm just going to quickly find that stuff. Hyperbolic functions, there we go. And they are on page 504 in the textbook. So the red and the blue formulas I wrote there are page 504, 7.3. So now the surface area is going to be 2 pi over 5 integral negative 4 to 4 of 1 plus cosine hyperbolic of 10x, because you have to double the argument, divided by 2 dx. That 2 will cancel the 2, so now we just have pi over 5. And now when you integrate 1, you get x, plus integral of cosine hyperbolic is sine hyperbolic 10x, and you need to divide by 10. You have a plus c at the end. And if you want to distribute pi over 5, you can, or if you want to leave it this way, you can. You can also factor 10 if you want. Yeah, you know, but this would be the answer that I would leave. And I'm definitely quitting those e's up there, because it's just, I might have a mistake somewhere, so they didn't click nicely. This problem needs to be doable using ease. It's just way too much mess and writing to solve it using ease. So we switch into hyperbolic, and as you can see, I'd say few steps, because I would be skipping a couple of steps along the way, but I just wrote everything out so you can see it. Oh, it's not plus c. Lies. Computed from negative 4 to 4. What does this stand for? Just do it, exactly. Okay, next problem. You will plug in a 4 and you'll have sine hyperbolic of 40. By the way, you know that you can compute hyperbolic functions on your TI-83, 84, right? Your calculator will have those functions hidden inside what is called the catalog button above value 0. You will have to use the second catalog, and you will scroll down. This catalog contains all of the functions that are so above 0, number 0, there is the word catalog. So you will scroll down, and it will have sine hyperbolic, cosine hyperbolic, tangent hyperbolic, and then their inverse as well. So sine hyperbolic inverse, cosine hyperbolic inverse, and tangent hyperbolic inverse. They're all on that list in your TI-83-84, but you have to go through the catalog. They don't have designated buttons like Trig does. So you can actually use that feature of the calculator to compute this. Now, you don't have the graphing calculator on the exam, so you don't have to worry about this. I mean, on the exam, you could still do it. You just say e to the 40 and e to the negative 40. So that's going to be annoying enough to compute. But yeah, it's doable. Excellent question to start off the evening. What's next question? Yes, sir.
Let R be the region bounded by the following curves. Y equals 12 absolute value of x, and y equals 13 minus x squared. And then it wants us to find the volume of the solid generated when R is revolved around the x-axis.
Perfect. All right. So we are going to graph this thing first. Without a graph, we can't do anything. So I'm going to draw my parabola starting at 13. It's going to drop down like this. And then I will have my absolute value shoot 45-degree up, there will be, these intersections need to happen on the same level. And we are revolving on the x-axis here. So the shape would be on the other side as well, like that. And it will be it will be a weird donut, right? There will be no hole in the donut. The donut will be round, like every donut is round, but on the inside of the donut, you would just have like a conical going in from both sides. So that's what it looks like. I mean, you need to turn this on a side to have. So this donut would be, it would not have a hole inside. It would be filled in donut, but it would actually, on the inside, it would have a hole that it's a perfect conical hole from both sides, right, as you rotate this. So we're rotating on x-axis. They did not give us any of these values. We have to figure out everything. We know the top is 13, the bottom is 0. We also need to figure out what kind of integral we are going to use, right? Now, I would like to use dx over here, obviously. I would like to use dx because you can see that dx is going to ride from 0 to whatever this value over here is. The lower part always rides on the absolute value function, and the top part always on the quadratic. So I would like to use dx for this integral. So now my axis of rotation and a dx are 90 degrees to each other, which means I am using the shell/washer method. Because I have two functions, it's a washer method. So rotation on x plus dx is disk/washer, and it's not a disk because I have two functions, right? So that's the way I decide what method to use. Now, I also see the symmetry here, so I'm going to compute half of the donut and then double it, because if I am to cut this like that, the left side of the donut and the right side of the donut are exactly the same volume-wise. So I'm just going to compute from 0 to whatever this x value is, and then I'm going to deal. And now that is really beneficial to us, because I would have to do two integrals, because this function here is negative x, and this function here on this side is a positive x. So I would have to have two separate integrals. So to find my volume, I will say 2 times, and now I have pi integral from 0 to whatever is in the box. And then I have my quadratic function, which is 13 minus x squared minus x squared. That's from the from absolute x, and then dx. So we need to understand, oh, it's a 12. Hold on. 12 x squared. There we go. That will mess up things. We need to understand that this piece over here is both x and negative x. So this side is x, this side is negative x. So that's what we have. And I only use x, so that's why I just have 12x. Otherwise, I would also have to have negative 12x. All right, so to find this, I'm going to set two equations equal to each other, which is 12x equals to 13 minus x squared. And as you can see, I don't care about the negative side because I will be doubling it. Move everything to the left. We get x squared plus 12x minus 13 equal to 0. And when you factor this puppy, you get x plus 13, x minus 1 equals to 0. X equals negative 13. We don't need that one. X equals 1 is the one we need. If you take a look at this line, it will go forever, and then when it will intersect one more time. That is the negative 13 solution that we don't need on x. The other one that we do need is the one for x equals 1. So the box up there is 1. So the volume is going to be 2 times and then pi. Very important. These two, I'll write it in blood, because of doubling the volume. I'm only computing a half. 2 pi is for the shell method. Single pi is for the disk and washer. But since I'm doubling it, that's why I put it here on the outside. Yeah.
Is there a way that I could write it using one integral from -1 to 1?
No, because you have a different function. Dx on this side will be writing a negative x. This problem cannot be solved with one integral in any way. So I'm just avoiding the -1 to 0 integral because it's perfectly symmetric. If this was not perfectly symmetric, you can't avoid it.
In my math lab, it only offered to write down one integral.
You double it. That's why.
Ah.
Integral 0 to 1. Now we have to FOIL all of this mess. 13 squared is 169 minus 26x plus x squared minus 144 x squared. Who comes up with this stuff? But okay. Equals a number. Well, actually, I'll integrate. Hold on. 2 pi. Oh, I can add these two together. Ooh, we simplify this. 169 minus 26x minus 143. See that? We saved right there. So this is 2 pi times, no, now the parenthesis, 169x minus 13x squared. 4 plus 4 is 8. That's not divisible by 3. You didn't.
I think you were supposed to do that to 4x. It's supposed to end up being, isn't it 13 minus x squared?
Yeah,
x to the 4?
Yeah, it should be 169 minus 26x squared plus x to the 4.
Yeah.
Oh, kill me now. Yes, everything you said is correct. And this one is still 120, so negative 170 x squared plus x to the 4th. I don't know how you do this. I really don't. There should be a monument to Calculus2 students in a courtyard somewhere.
Can you just take can you use washers and then take the right in the first quadrant? Once you get that area, just multiply by 2 because
It's not. You have two functions. You have to use washer. You can't use disk. It is a washer. I used the washer, right?
in the first quadrant.
That's exactly what I did. First quadrant. And that's why I multiply by 2. See, that's. Would you agree that this is a first quadrant?
Yeah.
That's exactly what I used. Only that. This is the top function squared minus the bottom function squared, right? And that's the top minus the bottom. From 0 to 1. So from 0, over here is a 1. And I'm doubling it because there is the other side as well. Yes?
So washer and disk are two different things.
Washer and disk. The washer is the more advanced, let's say, because you have two functions. Disk is a washer with the second function being 0.
Okay.
That's all it is. Okay, so what's going on over here?
It's x to the 4th minus 170x squared plus 169. No x.
Okay, so we got this, right?
Yeah, we just have to solve it.
Well, 170 over 3x cubed plus x to the 5 over 5 from 0 to 1. Oh, this is easy because you just plug in 1. 0 is going to kill everything anyway. So you have 169 minus 170 over 3 plus 1/5, and that's equal a number that you plug in.
So
Yes.
to follow up though, in my math lab, it did give us the bottom part of the integral was -1. Like they fixed that as part of the what you needed to fill in.
Then we could have just done it to 0 and still put a 2 in front.
Then you can do -1 to 0 and double that one.
Using the negative 12x line.
Okay.
And then you would use -12x inside. Yes. So for purposes of my MATLAB, most likely you will have 2 pi -1 to 0, and then you will have over here the standard, what was the first one? 13 minus x squared squared minus -12x squared dx. It's, yeah, still getting the same answer at the end. All right, cool. Michaela, do you have the hand?
Yeah, it was the same question with different numbers.
So I just have a quick question. So procedurally, you cannot find like the area in one quadrant, just multiply it by 2.
That's what we did.
Oh, okay.
We found the area in the first quadrant, rotated that one, and then just doubled the donut by times 2 for the other side. Double the volume, double the donut. Oh, fear this question. It cannot be read. It has to be shown. Wow. All right. Let's take a look. Find the curve that passes through point 1, 2, that has the arc length on the interval 2, 6, given by 2, 6, square root of 1 plus, I love this, 64 x to the -6 dx curve, which is y equals. Excellent. All right. What is the formula for length of the curve? Everyone. Integral a to b. Good. All right. Now we are going to compare these two piece by piece. Do we have these two matching? Yeah, we do. Do we have ones matching? Yes, we do. What else is matching over here? F prime squared is equal to 64x to the -6. Do we see that match? Do we? We do, right? And then dx matches dx. So now, what should I do? My job is to find y. Y is f of x, right? So what do? Square root both sides and then integrate to get f. So square root both sides, I will get f prime, no coughing, is equal to 8x to the -3. Integrate both sides. We get f of x equals to integral of 8 is, well, 8 is just 8, x to the -2 over -2 plus c, which is -4 over x squared plus c. Now we are using a point 1, 2. Use point 1, 2 to calculate c. So you have 2 equals -4 over 1 squared plus c. 2 equals -4 plus c. c equals 6. The function we're looking for, f of x, is -4 over x squared plus 6. If you are to punch this into my MATLAB, it should say fantastic.
Or excellent.
Or excellent, or good job. Good job is kind of not as, right? Yeah.
That's like the sticker.
When it says fantastic, like that's the one you always want to see, right? That one gets the biggest shot of dopamine. Like I'm gonna do more of this now. Yeah. They should add. I emailed them. They didn't do it. They should add exquisite. I like that word. The exquisite. Magnificent is another one. Yes. Stupendous. All right, that's off the thesaurus. Let's see what else we can come up. Any other questions? I'll answer another one, and then I'll move upstairs if anyone has additional questions. Do we have anything else?
Question: should we have the homework moved back more for 8, 1, 2, and 3?
Oh yeah, of course. Yeah. The entire chapter 8 will reopen over the spring break. We are only worrying about chapter 8, so 8.1, 8.2, 8.3, 8.4, 8.5. That all reopens from scratch. Entire spring break in a week after that, and we still have another 3 or 4 sections in chapter 8. Then we have 2 sections of chapter 9, and we're ready for exam 2. Give like 2 weeks, 3 weeks, right?
So the due date for that is going to change?
For chapter 8, yes. All of the chapter 8. Focus for the last 2 days is going to be chapters 6 and 7 for the first exam. Any other? Okay, if you have anything else, see me upstairs.